Okay, hi. So it's Wednesday or something. Hold on. My headphones are backwards. Okay, so I'm gonna graph h of x. This is actually in your booklet. So it's actually on page 14, I think. So just so you know. The other thing that we're gonna talk about next week is that we can write everything in vertex form. And so the letters mean the same thing. So A is my leading coefficient. That's my stretch factor. The H is a horizontal move. The K is a vertical move. So all that is still the same. So just be mindful of that. Okay, so the first thing I'm going to do, maybe I'll write this down first. I'm going to plot my vertex. So here it's not really a vertex, so we're going to call it like a locator point. But it's the same idea and it's in that same location. So my vertex or my locator point is actually -4, -8. Okay, the other thing, my graph, I think I need all my boxes though, so I'm going to maybe zoom in. Just like a little, oh, well, whatever. So -4, -8, so this is 2, 4, 6, 8. Maybe we'll just do that, 2, 4, 6, 8, 10, 12. So that was 10. Okay, so it's -4, -8, -4, -8, -4, -8, 2, 4, 6, 8, right here. Okay, so I did my vertex. Great, I love it. The next thing is that hopefully you graphed your parent function already, but like my radical looks like that. And so I'm knowing that it's going to increase from like left to right. And so I'm also noticing that I have a coefficient of 0.5. So normally my parent graph would go from like 0 to 1, right? Just like my quadratic, because it's kind of a quadratic on its side. But I'm going to plot my second point, and that's my first like jump. Okay, so that means that in one box it goes halfway. So just like think about that for a second. Maybe I'll make this be green. So in one box, right, it would go only like halfway. So then in two boxes, right, like all this stuff was sort of like increase, increase, increase. And so I have a point. Hold on, let me see if I'm doing this. So like in one box, I'm going halfway. And so I'm sort of going to have this like little jump here. So that doesn't help me very much. And so then I'm going to sort of think about, okay, what would my jump be after that? So, right, remember that things are kind of spread out for a radical. So I'm going to actually plug in a value. So in order to do my second step, so I'm going to zoom out a little bit. I'm going to say, let's plug in. I'm going to check 0. Right, so like if I had a little table. So then I have h of 0 equals 0.5. Oops, that's not a parenthesis. You didn't see that. So then 0 plus 4, which is 4, minus 8. So I did this for a reason because the square root of 4 is a whole number. So I'm kind of looking for my whole numbers. Times 2 minus 8. So order of operations, 1 minus 8, -7. So when I input 0, my output is 7. So that was 8. So here's actually 7. So that little half dot is correct, right? Like that's true. But I need a whole point. Me, myself, and I. Okay, the other thing is that because we have this leading coefficient of 0.5, and also I kind of want to like say that's why, I'm going to have something that's sort of like growing slowly. So I'm growing slowly. So my third thing, I'll write it and then I'll zoom back out. Third, I want to plot my third point. So I'm looking for a square number. Square number. Okay, So I have 4, right? So I have like, what would happen here? If I plug in 5, 5 plus 4 is 9. So I'm going to let x be 5. Here, let me show you why I did that. So I'm going to evaluate h of 5, 0.5 square root. If I plug in 5, I'm going to create 9. And I want a square number. What is that, 9? So then half of 9 is 4.5. Oh, that's going to give me a decimal. That's okay. Or sorry, it's not. It's half of 3. Oh dear, Miss Moose. But it's still 1.5 minus 8, which is, what is that, 6.5, I believe. Okay, so that's fine. I'm going to zoom in over here. So it was at 5 and negative 6.5. 5, negative 6.5. 5, negative. So here's 5, right? And then 2, 4, 6.5. So it's here. The other thing I know, just because like I'm here and like I already did the math, I'll do it in black, is that 12 and 6 is also a whole number. So just saying. So I'm going to really try. Oh wait, this is 2, 4, 6. Oh, that's too high. Sorry. Well, it wouldn't be a video if I hadn't made a mistake. Oh. Okay, wait, what was it? It was 5 and negative. Oops. Oh dear. Oh dear. Oh, that's funny. 5, negative 6.5. Okay, well, listen. 5. How do I zoom in? Oh my gosh, you guys. Y'all. Ugh, Miss Moose. Oh my gosh. Okay, it's fine. Calm down, Miss Moose. Okay, 5 and negative 6.5. Okay, I didn't label this, which is maybe my fault. This is negative 6. So 5 and negative 6.5 is here-ish. And then what I know that we didn't do is 12 and 6. Okay. Whew. Let's just be happy here. I want to zoom in this so I don't destroy this graph. Okay, sweeping motion. That is my function. It looks kind of little because of that leading coefficient. Yeah, so it's little because of that stretch factor. So it's growing slower. So it looks kind of like a horizontal line. I did not mean to have that be so long, and I'm sorry. Let's go to the next page. Okay, this one's cool because there's a flip that happens. So just like hang tight. So A is 1, which is great. I just want to like write that. H is 0. So that is fine. And K is also 0. So my vertex or my locator point is my origin. So this is like my vertex. You'll see though that it's the point of inflection. I never know how to spell locator. I don't have time for that right now. Okay, so my vertex, so same thing. Let's actually let me space this out a little bit based on what just happened. So let's have this be 1, 2, 3, 4, 5, 6, 7. Oh, but I need 8. Oh, 1, 2, 3, 4, 5, 6, 7, 8. Okay, just kidding. Just kidding. Oops, that's not my eraser at all. Oh, Miss Mouse. Okay, well, I tried. So that has to be 2, 4, 6, 8. We need 8 is the problem. Yes, 12, 14. Okay. And then let's same thing. 2, 4, 6, 8. Okay, so what's going to happen here is like, I'm going to make a table for this, but I'm going to think, so this is called a cube root, by the way. I didn't say that earlier. Ooh. So it's like a cubic, but it's a cube root. So a cubic looks like this. So this is y equals x cubed. A cube root looks like a square root, but with the little tail going the other way. Cube root. Okay, so I know that, right? So like, I'm happy because I have my origin. So I'm going to actually set up some like table situation. So first, let's get a table going here. And I'm going to focus on cube numbers. Focus on, I know. So what is great is that I have, I have -8. I'm going to have, because I want a whole number. I want -1, 0, 1, 8. This is for x. Oops. Okay. So when I evaluate this, so if I was going to plug in g of -8 into my, cube root, it's a double negative, so it's actually positive. So then that's +2. It is. The cube root of 1 is 1, but the sign does matter. So if it's a double negative, so same thing, g of -1, it's going to be negative times negative, which is positive. Yeah, so I have to input a positive in there to get that. I already know my vertex is 0, 0, because that's my vertex here. And then the cube root of 1 is again 1, but when I input 1 into my function, hold on, let me write it, because it's -x. So it's actually -1, which is -1. Negative times negative times negative is a positive times a negative, which is a negative. Oh no. So these are sort of like, they're mirrored, but see how like the symbols are flipping. I know, it's chaos. So let me actually set this up because I didn't do that. 2, 4, 6, -8. Do you see why I needed 8? Okay, so let's graph this. So this is 2. -1 is +1. 0 is 0. +1 is -1. So it's going to like swing down. And then 8 is -2. So it's like right below where I wrote it. Okay, well. All right, I'm going to try my best. Be nice. That was not very good. Oh my gosh. That's why I wanted to space it out. I guess I could have spaced it out. But there's like a swing that happens. It like swings down and then it like swings up. Okay. So really quick. This is 0, 0. This is our locator point. Is it like this or that? I feel like it's OR. Does anyone know? Are you talking to yourself at home and you're like, oh, it's OR. Okay, I was correct. Locator point. Which is like our vertex. It's the point of inflection. Yeah? So, again, this is from our little book. So I hope this helped. Sorry, it was kind of long. I didn't mean to do that, but you know how I get. So make a table. Double check with Desmos. I mean, honestly, that's always great to see. You're looking for whole points. And then cube numbers, just like for the record. Hold on. Like square numbers. And then like cube numbers. Right? So I have, well, like 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared, 9, 4, 16, 25, 36, 49, etc. Cube number, so 0 cubed is still 0. 1 cubed is also 1. 2 cubed is 8. 3 cubed is 27. So they get big fast. And then -1 cubed, you have to use a, what's it called? Parenthesis, right? So be careful with the negatives. Okay, bye. Love you.